How do you create an inequality from a graph? I'm going to show you two graphs, and we are going to create inequalities based on the information from the graphs. Just a reminder, for the next couple of examples, make sure you pause the video, write down all the work, and then replay the video to follow along with me to solve the inequalities. Here's example 1. We are going to write an inequality to represent the graph. So we first need to look up our necessary information, and I'm going to go ahead and draw the outline for an equation. We'll do y, and then you're going to need an inequality based on which side is shaded, mx plus b. Remember, we're going to replace the m with the slope and the b with the y-intercept, and we need to figure out what inequality will go inside the box. So the y stays the same. Since I'm shading below the graph, I'm going to use a less than, and since the line is solid, that has to be greater. The slope, I will count my slope, and so we're going up 1, 2, 3, 4, up 4, and over 1, 2. So it looks like we're going to have to reduce that slope, x. And then we need to have our y-intercept, and our y-intercept is where the line intercepts the y-axis at -4. So we write -4. And since we reduced the fraction, I'm going to simplify the equation. It's y less than or equal to 4 divided by 2 is 2x minus 4. Notice for my inequality symbol, if I'm shading below the graph, then I can use a less than or equal to. And if I had the shade above the graph, like if the shading was over here, it would have been a greater than, or it depends on if it's going to be equal to or not, but at least greater than symbol. Let me put that out too. Yeah. If you'd like to check the answer, go ahead and plug in a point. Let's say if we plug in the point right here, 0, 3, plug that point in and check to see if it's a true or false solution. If it's a true solution, check that point 0, 3. If it's a true solution, then we did the problem correctly. Okay? Bring your work, your check to class. Here is example 2. Write an inequality to represent the graph. Once again, it's going to need to be in slope-intercept form, so I can begin writing that out. Y box mx plus b. We're going to have to replace the m, and we're going to have to replace the b. M is with the slope, B is with the y-intercept, and we need to know which inequality we're using. So shading above the line, it's going to be a greater than or equal to. So I have y greater than or equal to, since we're shading above the line this way. My slope, let's see what my slope is. I'm going down 1. Oops, let's see how. 1, 2, 3, 4. Going down 4. So it's going to be -4 over, and then over 1, 2. Oh, looks like we have a very similar slope to the last inequality. Then x, and my y-intercept is right here, which is going to be at +4. So we're going to get a +4. Let's go and simplify. It's going to be y greater than or equal to -2x plus 4. And I'd like you to test the point. Why don't you go and test the point right here on the shaded side? That point is going to be 2, 2. Plug that in and see if we get a true or false solution. We should get a true solution.